Hello, my name is Tanzil Islam and this is my groupmate AEM Ridwan and Mekhala Mariam. This is our final project PID implemented line following robot, and we are going to talk about how we build our robot. Just like in our previous project, at first we need to create a world and a floor. Over here we have created a textured background, we have created a background light and a rectangular arena. After that we need to create the robot. Over here we have used a robot with two wheels. So we have used robot with two hinge joints, and we have used three sensors, one in the middle, one in the right, one on the left. We have made sure the sensor type is changed to infrared. After creating a robot, we need to build the tracks. To build the tracks, we went to the Tinkercad website and designed our own tracks. After designing it, we have downloaded and imported it to the webot software. After we have imported it to the webot software, we have to ensure the track is placed right above the surface. We have changed the color of the arena to white and the tracks to black so that the sensors can sense and differentiate the track and surface very well, because sensors work on color. Infrared sensors work on color. After that, my teammate will talk about the next part.
Yes, Mekhala, start.
This is our LFR. Our LFR has three IR sensors, left, right, and middle. And we have observed how it detects the light color. Here we can see in this screen that on the white surface it is sensing the values of the sensors as below 400, and on the black surface it is sensing the value up then more than 400. So we have set our if else condition on that wise, and when it is working, we have calculated the conditions as if we see on this case, we can see that the middle one has greater than 400, so it is on track. So our LFR has to go straight, so our LFR's left speed and right speed should be maximum. So we have set this on this based on these cases, and according to this, and we have set all other cases. Now Ridwan, you can continue.
Okay, so I will explain now how PID algorithm works. So for PID, we have to look at some things here. Uh, if we look at a graph like this, if this is our goal state, so PID works like if our function for reaching this goal is fx, then the proportion works like it will take our it will push our car or our function in a way that it will cross the threshold, and then it will calculate error in every second here. Then it will calculate again error, and then again it will see that we have already crossed our goal state. Then it will again decrease, and then again increase, again decrease, again increase. So in this way it will just iterate like a damping sine wave. And if we take average of this value, we can see that we will reach somewhere up here. Our average value will be somewhere up here, which is not exactly what we need, which is a bit less. So for that we need integration. Integration improves this value. It takes us from here to there, but this is not in the all conditions. Sometimes we don't need integration. We can get to the perfect value without the integration. And then derivative does flats this curve. It just decreases this spike here, it just flattens our curve like this. We will be like going from here to here, again here. uh, it will do something like this. So uh, what is our fx then in our LFR case? We try to build 3 LFR with two different function fx function. We used 4 array for this one and this one, and we used 5 array for this one. So the 5 array LFR with PID works better because of the smoothness. uh, we'll explain how the smoothness works. So this is our 4 array multiplier. First of all, we have converted our array sensor array value to digital value. Like if it is a black surface, then it will give us a 0, and if it is white surface, then it will give us a 1. And then we have calculated, and then we did what, we have just multiplied our sensor values, like it's like 0 0 0 1. If it's just the line is on the right side, then it will just multiply 1 with our 3000, then our value is 3000. After that we have subtracted 1500 from it, which means our goal state is in that case 1500, which is the center. Okay, the average at the center, it means that our line is in the center. This is one way we used, and the other way we used is in PID 3 here. We used a minus value and positive value. If the value is minus 1000, then it is in the left side. If it is in the in two sensor of the left side, then it will give us minus 1300. And if it is in the right side of two sensor, then it will give 1300. So this way we have calculated our summation of error. Then this is our error. We multiplied our error value with kp. Now you may ask what is kp. Now Mekhala will explain the kp part and the rest. Mekhala, can you explain?
KP is the proportional
Mekhala, continue.
KP is our proportional constant, and this proportional constant has to be calibrated by multiplying with the array values, and then we use the derivative constant. Derivative constant is KD, and here KD is calibrated as the last current error minus the last error. So this KD and KP is used to calculate the motor speed, and for this and after this we calculate our left speed and right speed by using those motor speed as summing up with the base speed of we take the difference from the base speed, and then we go to the if else if condition. If we check if the speed is greater than 10, because the threshold speed is 10, so that's why we have this if condition. And then if the absolute value of this speed is greater than 10, we will put the value as 10, set the value as 10, and that's all.
Okay.
And let's say the
That's why we set our LFR speed. So if you see here, if I fast forward, you can see that the green LFR is much more smoother because it has more IR sensor, like 5 IR sensor. If we increase the number of IR sensor, it gets more smoother. It never gets out of the line. You can see this red LFR sometimes goes out of the line, but it comes back as it memorizes its last move, and it finds the line again. But if we increase our number of sensor, our PID algorithm will work much more better. Thank you. This is Ridwan, Mekhala, and
Tam.
Tanzid.
Tan, tan, tan,
Ridwan,
tan.
Mekhala, and
Yeah, yeah.
Tanzid.